Once again, welcome to this course on machine learning. Usually when I do courses on machine learning, I call it data science. That is the first place where I'm calling it machine learning. So welcome to the course on machine learning with data science in perspective. Yep. We have a long way to go and we have a lot of things to cover. And the 4 hours that we have today and 4 hours that we have tomorrow will be kind of tight to cover all those things in one shot. So I'm going to minimize my other things which I used to do. Usually I get introduced to people, which I'll leave it for later part. Maybe we'll get introduced to each other as we go down the road, right? Before I start, any questions? So let me start with machine learning and data science. Have you heard of this word before? Machine learning. What do you think it is? Machine learning is a kind of programming which is based on data. As he said, he rightly used the word data, right? It's very unlike the traditional programs that we have been writing in the last so many years in Java, Python, and so many other places. Here, machine learning will be entirely data-based. It will be based on data. What do you mean by that? You'll come to know when you do the hands-on. The concept of machine learning is not new. Though we are hearing about this now, the concept of machine learning actually grew in 1959. At that time itself, people were trying to build systems which could do things on their own with very minimal human interaction. But given the very limited technology they had at that time, they could not achieve it. But today, thanks to big data, thanks to other technologies associated with big data, cloud especially, and thanks to technologies such as Spark, distributed processing frameworks, it is possible to do all these things now. And that's why it's becoming so famous right now. It's hot. Data science, machine learning is really hot today in the market. Everybody wants to do it. But then there are very strong prerequisites to get into this and master this field, right? So it's a very old concept, but today it's coming into shape because of the technologies. And I believe you already have going through training on Spark, right? That's the right technology to be in, honestly. Okay, so what is machine learning? It is basically a process of enabling your systems, computer-based systems, to do things for you. You basically teach them to do things for you. And this teaching that you do, it requires not programming, it requires data and it requires statistics and mathematics. It is very unlike the traditional programs that we have been writing, where we write the rules-based, as I said, instructions and the machine does things for us. But here, it will be data, stats and maths. Don't look at me like that. Stats is a wonderful subject. It's purely common sense. And you know, most of you already know statistics. When I do my statistics trainings, that is one of the things I end up proving, that you already know statistics. Probably you don't know the jargons like analysis of variance or F-test. What do these things stand for? But we do it every day in life. We use it day to day. So statistics is pure common sense. Don't feel bad about it. You already know it. And whatever you know is sufficient for us to do machine learning. So the ability to do the tasks for these systems comes through a concept called model. Not always, but most of the time, it comes through a concept called model. The models which are generated using statistics and mathematics on the data, they are supposed to represent the process which has generated the data. This might be slightly confusing to you. Let me put it in a simple words. We'll start with a simple model. When you sit down and build models, that model will be come out in form of a mathematical equation, okay, where it will take a set of inputs, and based on the inputs you provide, it will give you a set of outputs. Let me ask you one basic question. All of you, most of you have automobiles with you, two-wheelers or four-wheelers. Anybody with three-wheelers? I used to use three-wheelers. I use three-wheelers very often. Most of us have two-wheelers and four-wheelers. Okay. Now today, in the market, you want to sell a four-wheeler, second-hand four-wheeler. What are the different parameters on the basis of which you will decide the price of that four-wheeler? Number of years, how old the automobile is. Anybody else? Would you like to take a shot? Which one do you drive? Two-wheeler. Suppose you want to go and buy a second-hand two-wheeler today. So how will you decide the price of the two-wheeler? Model, okay. She's added model to your thing. Then how many years? Anything else? Anybody would like to add? Sorry? How many kilometers it's already? Absolutely. What is the current price of a new vehicle of the same model? Accidental history. So what you people are doing right now is, you people are telling me the various things that you'll consider to decide the price. Price is the output. The various things that you consider is the input. All these inputs will be fed into a formula. The formula will come out with a price. Hopefully in the market, the price that your formula comes out with, hopefully that is the price at which these things are available in the market. This formula that you came out with, this formula is your model. Now the thing is, how do you come out with this formula? On what basis do you come out with this formula? On what basis you would say price is a function of how many kilometers it ran, accidental history, how old it is, which model, how do you say? So she's going to prioritize each one of these parameters. Basically, she's giving weights to each one of the parameters. But then your weights may not be same as the weight he gives. The weight that he gives may not be the same as the weight he gives. So all of you may have different weights. So what I do here is, I take data from a lot of past people who have sold their automobiles. I take all the data. That data I feed through an algorithm. That algorithm finds out a best combination of weights for each one of these dimensions, and it comes out with the formula. That formula represents the universe. All your individual weights for each one of those parameters have been considered in that formula, and the weights that the formula comes out with, that weight represents all of your weights, right? That is called a model. So come back to this line. The model generated represents the behavior of, instead of processes, it will be people who have earlier performed this task. So I go back to history. I take all the second-hand sales data with me. I run this algorithm on the second-hand sales data. It generates this model for me. That model is supposed to represent all of your behaviors. The more the volume of data you use to generate this model. Right now we have 40 students in the class. Good number. Statistically 30 is considered as a good number. Anything above 30. Suppose I had taken data from 400 people. Then the formula that is generated becomes even more representative than it would be if you generated out of 40, right? So the model is generated from huge volumes of data, and huge volumes of data today is not a problem. We have big data with us. When I'm working on big data, I'm working on machine learning using Spark, I have access to terabytes of data sets. Compare this to some 15 years ago. I was in market research, where I used to do market research for PepsiCo, Hush Puppies, Kentucky Fried Chicken, and so on and so forth, where we used to build models using just a few thousand data points. Today, we have access to terabytes of data. The more representative the data is of the real world, the better your model will be, or more accurate your model will be. You know, you come out with, I'm really surprised that you came out to this point. What he's actually pointing out to is, every data point has a life. Beyond certain number of years, the data became saved. So I give weightage to the data based on how old the data is. The older the data is, lesser the weightage it gets. So we can adjust all those things. We can tell the algorithm to do all those things, and it will come out with a model. But keep in mind, before we start building the model, the first and foremost very important thing is the data on which you build the model. That data is called sample. And your model is supposed to represent the behavior of the entire world outside. The entire world outside is called population or the universe. Hence, for your model to be accurate and good, the sample data on which you built the model, that sample data should be true representative of the population outside. What do you mean by that? Did you get this? Did you understand what I'm saying? So can somebody elaborate on what I said and tell me what exactly I meant? I don't know what I meant. It should not be biased. It should be, then what is the second thing you said? Relevant. Real random sample. Yeah. Now, suppose I want to find out the average height of people in this class. And I don't have the time to do that, so I restrict myself to this section. I found out all of their height, sum it up, and divide the number of people here. Will that be a good representation of the average height of this class? No. Maybe, may not be. The reason being, the variance that you see here in the data points and the variance that you see here in the data point, the variances are different. A sample becomes a true representative when it captures all the possible variations in the data in the population. This is a mantra of machine learning data science. Whenever you build models, if you're building a model on a sample which is biased, the model will completely mislead you. And since you're going to use this model to do business, you're going to mislead your business. So in data science, machine learning, the first thing you need to learn is how do you make sure your sample is a true representative of the population. Some problem statements may require a very simple management technique like 5 whys, where we do root cause analysis. We don't need machine learning for that. Machine learning is specifically required in certain cases where we cannot transfer our knowledge into rules-based programs.